All right, so we're going to do one or two more examples here of that big theorem from chapter 4 that we saw in the last videos. So before I start the new example, I want to say that what we're talking about with these field extensions, we don't always know when things are fields or not. So our first example is going to deal with the ring Q adjoin 2 to the 1/3. Okay, and notice when we first defined this like Q adjoin alpha thing, they are rings. We defined them as rings. Sometimes they're fields. So you proved back in chapter 2 that Q adjoin root 2 is actually a field. We knew how to write the multiplicative inverse of things. We could write 1 over a plus b root 2 as an element of Q adjoin root 2. And then for homework you did 1 over a plus b root 2 plus c root 3 plus d root 6. So we knew that Q adjoin root 2 root 3 was a field. Right now, Q adjoin 2 to the 1/3, we don't know if that's a field or not. That is what's coming up in the rest of chapter 4, figuring out when these rings are fields and when they're not. But for now, we're just going to take for granted that this thing is a field, and we'll see why that is later. So this is a field, and it's a field extension of Q. And so I want to know what's the index of that field extension. So that means I'm going to take this generic element, a plus b times 2 to the 1/3 plus c times 2 to the 2/3. That's what our generic elements in Q adjoin 2 to the 1/3 looked like. We didn't need 2 to the 3/3 because that was back to the rationals again. That was back to the a term. So this is what our generic element looked like, and we wanted to split that up as scalars from Q, basis vectors from Q adjoin root 3. And we wanted to do as many of those as we needed to. And hopefully you've got this idea down by now. So our scalars are going to be the A and the B and the C. And our basis vectors are going to be 1, 2 to the 1/3, and 2 to the 2/3. So our basis was 1, 2 to the 1/3, 2 to the 2/3. Okay. And so our field extension was degree 3. The dimension of the vector space was 3. All right, so let's do a field extension from there. So let's take Q adjoin 2 to the 1/3 as our base field. And our extension from there, let's say we tack on root 3. So we're going to have a field extension from Q adjoin 2 to the 1/3. We're extending to Q adjoin 2 to the 1/3 and root 3. And so again, I want to know what's the degree of that. And here, hopefully you've got the feel for what that Q adjoin 2 to the 1/3 root 3 looks like. The generic elements there are going to be A. We're going to need a B times 2 to the 1/3. We're going to need a C times 2 to the 2/3. We need a D times root 3 because we have to include root 3 now. And then we had this, it has to be closed under multiplication, and so we needed an E times 2 to the 1/3 times root 3, and we needed an F times 2 to the 2/3 times root 3. Okay? And we think that that should be it. Hopefully that seems like the right collection of elements to you. And so we should be able to break this up and figure out what's our basis. What we'll do is look at Q adjoin 2 to the 1/3. Those are our scalars, right? And so I want to pull those elements out. And so here is 1. That's an element from Q adjoin 2 to the 1/3. And notice if we factor out a root 3 from this whole string that's left, then we'll have another element from Q adjoin 2 to the 1/3. It looks like that. And so our basis vectors are the 1 and the root 3. So our basis here is just 1 and root 3. And so our degree of this field extension is 2. And now notice the degree of the field extension here was 3. The degree of the field extension here was 2. And so what we have, if we drew this little picture, Q was our base field, and then we had an extension by adding in 2 to the 1/3 to our ring. And then from there we added in, we had 2 to the 1/3, and we also added in root 3. The degree of Q to adjoin 2 to the 1/3 over Q was 3. The degree of Q and 2 to the 1/3 root 3 over Q adjoin 2 to the 1/3 was 2. And so the degree of the top to bottom field extension is the product, is 6. So that's what the theorem said. And notice that we already saw that. When we wrote down our generic element up here, we had A, B, C, D, E, F. So we had 6 elements. In fact, the basis for Q adjoin 2 to the 1/3 and root 3 over Q, we know is the product of these two bases that we have here. So it's the 1, 2 to the 1/3, 2 to the 2/3, all of those times 1, all of those times root 3. And that's exactly what we did when we wrote down our generic element. We had A times 1, B times 2 to the 1/3, and then we had D times root 3 times the 1, and E times 2 to the 1/3 times root 3. So our basis here is going to be the product of those two bases. So 1 times 1, 2 to the 1/3, 1 times 2 to the 1/3, 1 times 2 to the 2/3, and then root 3 times 1, root 3 times 2 to the 1/3, and root 3 times 2 to the 2/3. And we end up with those 6 elements for our basis. All right, so you'll do one more of these for homework, just to try again and get this feel for how the bases are related, how the degrees of the field extensions are related.